camera guy, and I have some work to do today. My wife told me I have to exercise more. Enterprise DevOps. Just these two words together. I mean, the word enterprise, I mean, it's supposed to be such a good word, right? Enterprise, an enterprising young man. But in the IT business, as a developer, enterprise is hell. Enterprise, supposed to be something that rises up. But in the development world, when you work in an enterprise, everyone is keeping you down. You try to do stuff and you can't. You want to do things right, but you can't. Enterprise in the IT world is wrong. So when we connect enterprise with DevOps, maybe we're trying to make that better. By the way, thank you for getting rid of the Twitter feed here. I appreciate it. It was very interesting, but it definitely takes everyone away from the focus. However, this is going to be an interesting issue. I realize we're inside a big CPU. That's pretty cool. Hi, everybody. My name is Roy Osherove. I'm doing a workshop on enterprise DevOps on Sunday. If you're interested, come check it out. A little bit about me. I come from a background of software development. I've worked on anything in many different parts, many different types of work as a developer, team lead, architect, CTO, DevOps, testing, a bunch of stuff. I wrote a book about all the mistakes I made when I tried to do unit testing, and I called it The Art of Unit Testing. And I do believe that the best way to learn is to make mistakes. And I am a really, really good student. And for example, for many years, I believed that unit testing is the thing that will save us from this hell of development that we get into after the code lives for a while. That unit testing and test-driven development is the answer. And it's definitely part of the answer, but it's not enough. Because when I became a team lead, I wanted to get all my team to do unit testing and TDD, all the stuff that I believed in. And everyone said, yeah, great, let's do it. And nobody did it. I said, let's do it. And they said, yeah, you know what, you're right, let's do it. This time we'll do it for real. And nobody did it. And as a team lead, I failed to understand why are the things that we believe in and the things that are actually happening in the real world are different from each other. Because everyone agrees that it's a good thing. But you know what the main excuse is, right? We don't have, thank you, time. We don't have time. We don't have the resources. We don't have the skills. And even if we did have the time, maybe we're measured on the wrong thing. Maybe we're measured not on the quality of our code, but on the cost and the speed of delivery. But the quality can go to hell. Maybe we're not even measured on that. We're just measured on delivering to a different team instead of delivering to a customer. So my struggles and my failures as a team lead made a second book called Elastic Leadership. And I'm currently working on a third book. And this book is all about trying to connect these two worlds together. It's not just about unit testing, but it's a combination of technical work and leadership. And leadership not just for managers or project managers. We're talking about leadership at the personal level. Anyone who's an expert at something can be a leader. If they're not a leader, they're what I call a bottleneck. A bottleneck, a bus factor. Who knows what a bus factor is? Raise your hand. Okay. Some people here know, very little. A bus factor is how many people have to get hit by a bus for the team to stop working. Okay? When I was living in Norway, I usually said how many people have to be in a ski accident for that team to stop working. But still, it's the same thing. There's always this one person who knows how the build works, the one person who knows how that can make a decision on architecture. There are many bottlenecks in teams. And part of the reason that we get stuck in enterprise today is about bottlenecks. It's about those bus factors. And part of the thing that DevOps tries to bring to the picture, and I'll talk about what that means to me, is how do we create those teams of people that can solve their own problems, who are not bottlenecks to each other, and do not depend on anyone else to do their job? How do we create an organization based on pipelines, really? So that's still in progress. What we'll talk about today, a quick intro into DevOps, but not the DevOps that you may know, but more DevOps at the enterprise level. For the past 5 years, I've worked at some of the biggest companies, biggest insurance, banks, etc., as a consultant, helping to not just deliver a message, but really to try to implement from the ground up and from the top down, continuous delivery, test-driven development, basically DevOps rules, DevOps ideas. And it starts from both sides. You cannot just do it from one of them. And I'll talk about what are the things, what's the main vision that we're trying to accomplish, and specifically in large organizations, what are the things that are stopping those things from happening? Because if you're in a small team, there's very little that's stopping you from being able to do many different things. But as you go into different types of industries and different sizes of teams, you get into these interesting problems like compliance, right? You want to deploy. You are a big believer in continuous delivery and continuous deployment. I want to create a CI and a CD pipeline that deploys all the way to production. And you're all like going, yeah, let's do this. And then security guy goes and says, on my dead body. You will never deploy to production directly on my dead body. And we'll talk about why that happens, because for everything that happens in an organization, and of course outside of that, but we'll keep in focus here, everyone that behaves in a specific way in an organization has a reason to, or usually has multiple reasons to. And part of the reasons are the metrics that we use, how people are measured, what are the incentives. So we'll talk about introduction, the adoption challenges, and what to expect during an adoption process. Just to understand what DevOps is to me, because DevOps is really made up of many different things. There is really the best definition that I've heard is from a person who was my mentor for the past few years, Michael Wagner. It is what modern IT really looks like. It's a combination of multiple things, but it's the most advanced form of software engineering. Now, in a DevOps world, everything becomes software. Everything, security, infrastructure, compliance, policies, everything becomes a form of software. So we're talking about software engineering at the enterprise scale, the organizational scale, where the end game, what we're trying to achieve is velocity, the speed, which is back to the agile principles and the extreme programming and all that stuff and the scrums and whatever, but the end game is velocity. We want to be fast in the market. We want to deliver value fast so we can be competitive. We want to be able to get feedback loops so we can understand what we're doing better and better. Now, in a DevOps world, the main thing that we have to understand when we're trying to adopt a DevOps mindset is to understand that DevOps is based on a value stream. If we want to deliver value, there's a value stream. It's not specifically a pipeline. It is basically the set of actions from the moment where a thing has been, an idea is in someone's head to the point where it's actually running in production at paying customers' hands. This flow, this value stream, is our entry point. It is the entry point for any kind of adoption because it is the thing that gives us some information, some base information. How long does it take us to ship a single feature today? How do we know if we're improving if we don't measure, right? Measure, get feedback, improve. And many adoptions start without measurements. They just start because people know it's the right thing to do. I'll just start this. I know it's the right thing in my heart that we should do this or we should do that. But how do I communicate that there is progress, that we're actually doing something better? For example, in some organizations, the developers in the enterprise, right, in specific a business unit, let's say, they've decided they'll create their own little bubble because they're fed up with the standard IT and all their blocking of getting infrastructure and environments, so they create their own little bubble. And in that bubble, they're running CI, and they're running unit test, and they have their own infrastructure, and everything's going perfect. So locally, they're going really, really fast. But still, they're hitting this kind of the end of the bubble. They're hitting the end of the bubble where they actually have to deliver to the outside, to the inside of the organization, but the outside of their team. And in that place, everything gets stuck again. And not only does it get stuck, sometimes it gets even worse, because now the deployment methods between the different groups have changed. Sometimes there are multiple compilation steps between those groups. Sometimes there are security and compliance issues, so everything you did before doesn't even matter because someone is going to do it again manually. It actually sometimes doubles the time, and it actually creates more miscommunication and more mistrust between the different groups. Because now there's an incumbent IT, and then there's the new and upcoming IT, and they're threatening those people, whether it's explicit or non-explicit. So now you have almost a psychological war of people defending their current rights to exist versus the new way with tools. Now, they're both working, they're supposed to be working on the same thing, on the same task. They're supposed to be using the same metrics, but really, now there's actually a lot of infighting and a lot of back and forth, wasted, not actually delivering anything. So what are the things we want to measure? The cycle time or the lead time to change. How long does it take a single feature to move from the time it's actually created somewhere in the system as a single sentence maybe, or as a single document, to the point where it's actually delivered in production. And we're not talking about sprints, etc. Because a single story can go through a sprint, and then it can wait for the end of the next sprint. But it's not about we are releasing every 3 months to production, so the cycle time is 3 months. That's not necessarily true. A single story can wait multiple releases before being delivered, right? Or it can be done and then wait for a month and a half before it can actually be delivered. So the cycle time and the value stream that we create from it give us a picture of where the main bottlenecks are, where the main wastes are. Where can we even start? And sometimes where we want to start is not even in where developers work today. Sometimes it's in the acquisition, sometimes it's in the requirements phase, project management, all the PMO offices, sometimes it's in compliance, sometimes it's all of them together. But fixing one of them might bring you much less value than fixing another one upstream. Mean time to recovery. Mean time to recovery is a very interesting metric because today most organizations or most IT organizations do not measure mean time to recovery. They measure something else. Do you know what that is? Mean time to failure. Mean time to failure, or MTTR, is something that many IT and operations people have to basically be measured on. And it may be explicit, maybe not explicit. But the idea is that mean time to failure is how much time goes between failures in production. So what if I'm the IT person, if I'm the operations person, what I'm measured on is how much time goes on between failures. So my objective is to make that time shorter or bigger? What do you think? Bigger. How do you make sure that there is you lengthen the time between failures in production? What's the best way to prevent failure in production? Do you know? Don't deploy. There you go. So my incentive as the operations person is to prevent you from deploying. That's how I do my job. That's how I measure. I get more money at the end of the year if you deploy less. Because the risk is much higher. So every time someone wants to make a change, every time someone wants to go faster, there is this, have you heard this term before? The department of no? The department of no. And as developers, maybe you've heard this, we'll just ask them to do this. Oh, you know what they'll say. They'll just say no. They'll just say this. And so it's a department of no, but they have a good reason. And if you were in their position, you would probably have done the same thing. Because the way we're measured, the way we're compensated, depends on how we do our work. So mean time to recovery is the opposite of that. In a DevOps world, we can still measure mean time to failure, but we also measure mean time to recovery. And mean time to recovery takes precedence. And the idea is that once there is a failure, I want to measure how long it takes me to recover from that failure in production. So now as an operations person, my incentive is to make the failure be as short as possible, but not to prevent it, just not lengthen the failure. So now my incentive is to work with development on what are the best ways to recover from failure, of creating systems that are more resilient, of creating systems that are easier to roll back, or maybe coming up with different deployment tactics like blue-green, et cetera, so that mean time to recovery is much shorter. So that's an example where it doesn't actually matter how much people believe in something in the organization. If the institution is measuring you and giving you the wrong incentives, you will do the wrong thing, although for the organization it's the right thing. So mean time to recovery is the second important metric that we measure in a DevOps world. Change failure rate. The idea is that once you deploy, how many failures do you have? So this could be either one of two things. Either the amount of errors that you find in production or how many different types of bugs you have to fix after deployment, and that should go down considerably in a DevOps and automation world. Or you can also measure it in, if I put in 100% of features, let's say 10 features into production in my deployment, what percentage of those features has had a bug in them in production or a problem in production? And also that number should go down considerably, because the idea is that we want to build quality in. We want to, I like all these, it's very I just spent a few years in America, so I'm filled with all these American sentences in my head. Shift left, lift and shift, build quality in. A lot of these kind of phrases, and it's really nice to say them, it makes you feel good, but really what it means is that we do not wait and deliver over the wall. We build something while we build the code. We do everything during the building of the code and not after. So we shift left, or in your case, it would be my right, so that in a Kanban board, everything happens much earlier. All the different types of tests, etc. We want to find out much faster if something is not going to work in production. And that requires different things. For example, getting a production type of environment where you can run the test on continuously. Ephemeral environments or temporary environments are a great idea for that. So we measure that. And release frequency. How many releases per year, per month, per day, doesn't matter. Releases we are actually doing now. There is a difference between a release and deployment to production. But the main idea is that if as an organization I want to be faster, I want to have more marketing events, I want to have more abilities to be competitive. So we're talking about formal releases that we can tell our customers about officially that says we have fixed this issue, we now have this problem solved, we now have this new feature. We can deploy much faster than we can release. For example, the point of this, of part of this exercise is that development should be much faster than the marketing company inside the company, the marketing organization. So deployment can happen multiple times a day, and marketing just decides one day that this is going to be the release. They announce a release on something that might have already happened. And that's what we want to have. We want to not be the bottleneck for any type of the organization, for marketing specifically. So we don't want marketing to wait for us for 3 months before they can announce a release. We want to be so fast that they can tell us, hold on, don't publish it just yet. When we get to that, we are starting to be in a good place. When we are faster than what the organization is trying to do. So really the combination of agile principles and continuous delivery principles gives us this world of what DevOps really is trying to do. And DevOps is really based on the continuous delivery ideas. If you take the world of continuous delivery, there are some special game rules that we want to apply, and those apply throughout the organization. For example, the process of deploying and releasing must be repeatable and reliable. We want to do this so that we can prevent all those issues in production. This is the way we test our deployment scripts, by running them much earlier. We want to automate everything down to bare metal. And that means specifically that there is development is coming into the IT world, infrastructure. Infrastructure becomes a part of development. And I'll show what an example of a development and infrastructure pipeline looks like. We want everything to be in source control, and we want everything to be to become easier. So what that means is, whenever you find an issue, something that's difficult to do, focus on it so it becomes less difficult to do. And this is actually also true in life. It's a good way to learn. So if something is difficult for you to do, it means you're learning something new. But in an IT world, in a DevOps world, what this means is that if there's something that you're dreading to do as a team, it means that you have to find a better way to do it, either automation or some other type, or reorganization or refactoring of the process. Everything in source control means everything. Everything from policy documents to scripts to infrastructure. Everything can be versioned based on the current release. Because if you want to either reiterate or recall a specific release, or we want to have an audit trail for compliance reasons, we want everything to be in source control tied to a specific version of the application, including infrastructure scripts, etc. Everyone has responsibility for the release process. This is very important. It's, in many organizations, you have this kind of splitting of the organization into groups that just hand over to different groups. You know, did my job, I did my job, I don't care anymore, etc. One of the ways that that DevOps at the enterprise works is by creating these pipelines that everyone works on. Everyone is targeted on a pipeline, and every task, every gate, every call gate happens in a pipeline. So if a pipeline fails, everyone knows about it. And when you're doing your work, you can see that you're affecting the pipeline, and that pipeline goes all the way to delivery, or as much delivery as you can until someone has to click a button. And the continuous improvement, I'll talk about that a bit later. And specifically, in a pipeline world, in continuous delivery in DevOps, we're talking about building things only once. One of the most common things in enterprises is that things are built multiple times by different departments. The department of deployment to production, and the department of staging, and the testing, and everything is very, very waterfallish. And a lot of times they're also using different branches in source control, and then the source code is checked into those branches, and someone then literally recompiles, or they have their own little automated pipeline. But the problem is that every time you recompile, you're creating the application again, the binary again. So all the tests that you ran before don't matter anymore, because you just recompiled everything. We don't know that the compilation process is the same. It might have happened in a different type of machine, different flags, we don't know. Might have happened manually. And so the tests that have passed before might fail now. But the problem is that different types of tests are run at different types of compilations. And so just the fact that your unit tests were passing here doesn't mean that they will be passing in production. And that's one of the biggest problems, that organizations have a blind spot. They recreate the application between these different tiers or departments. The smoke testing of deployment. So we want to run deployment tests, and that happens, of course, in most companies, in startups. But in many companies, the smoke testing is manual, it's not automated, and it's not repeatable. And we want to smoke test and add to the smoke test continuously on new features that have been added. And if anything fails, stop the line. This is also something that doesn't happen a lot in large organizations. Something has failed, but the deployment still continues. So what I mean is that different teams are working together. One team is not delivering, or they have a problem. So they either just merge part of their work, or they do specific selecting of specific pieces. They merge just some of that stuff, even though locally stuff is not passing. And then they let someone else handle all these problems down the line. And that creates a huge overload. So the idea is that if we're all using the same pipeline and the pipeline fails, we have to fix it. There is no other way. There is no other pipeline. There is no parallel branching. The pipeline fails, we cannot actually deliver. And that scares the hell out of many people. We're all working on the same pipeline. So if I break the build, no one can work, no one can check in. No, that's why God created feature flags. etc. But it doesn't mean that you cannot run your tests on that same pipeline. You can run tests in different environments with feature flags enabled, etc. You can create parts of the features and turn them on or off in different environments. But you don't have to create this huge system where some people get some of the code, other people get other pieces of the code. That's one of the huge problems, that nobody knows what is the final and single version of the code and the binary. So if you build the binary once at the beginning, and then you put it in an Artifactory or a Nexus, or even on a file server somewhere with a specific version, and then that binary is used either to deploy or to run tests. But that binary is the only thing that's being used for anything else after. There is a single known version. Everything else becomes secondary, because if what you deliver is a binary, not source code, then you have a specific set of truths. You can say, this is the single point of truth. Here's an example of a simple pipeline. In a pipeline world, everything happens from left to right. We all know this, and you have different columns. The columns change based on project. So commit, acceptance, etc. The commit phase is where you actually build the binary. And different projects might have different columns, but one of the things that you can see here is that the moving between stages can be manual or automatic. And in a DevOps adoption process, the organization is usually not immediately ready to just accept deploying to production. So some of the things are still happening manually. Someone actually has to click a button for things to go all the way to production. But it's really setting up a flag somewhere in the system to enable or disable the manual deployment. So not the manual deployment, the manual clicking of automated deployment. So we want the deployment to happen just after the same binary has gone through all the tests on the left. Okay? And this is one of the most important parts. The binary is only created in the first stage. Everything that happens after, all the way to the right, is basically the same binary passed over and then being run with different tests. Here is a different view of a pipeline. And in a DevOps world, I said everything is code. If everything is code, it means that infrastructure is code as well. So at the top, we have what developers are building. At the bottom, we have infrastructure developers. And they're both using source control. So while developers on the application are building a specific feature, developers on the infrastructure are either building or planning or changing the infrastructure for the environment where that feature is being run and maintained. So when they commit their infrastructure scripts, which could be anything from Terraform or Chef or Puppet or anything like that, they will automatically run through a pipeline that validates the packages, deploys the infrastructure, and allows to deploy the application on that infrastructure. And they're both using the same source control. So maybe that could mean two different things. One is that when I'm building my application and I'm checking in a feature is built and is then deployed on the latest version of the infrastructure, and then all the tests are running, and then that infrastructure is killed. That's an example of a temporary environment. Another option that could happen here is that whenever the infrastructure is being saved, or whenever the code is being changed, a new version of the infrastructure image is created. So you deploy the infrastructure, you deploy the code, and then you create an image or a Docker image or any kind of containment, and that becomes your environment template with an application pre-deployed on that environment. And from that moment on, your binary is the environment. Basically, you take that environment and you can instantiate it in parallel or multiple times, but you run all the tests on the same environment or the same type of environment. The environment is the binary. Now, your production will also become that environment. So if you're using different types of deployment mechanisms, such as blue-green or I forgot the name of it. But the idea is that when you deploy to production, you actually instantiate a new environment, you pass all the needed data, you sync all the data, and then you can either move some of the users slowly, or move all of the users, or move by feature flags, or whatever you want to do. But the environment has already been tested. You don't actually have to deploy the application. So some organizations have the anti-pattern of that, and the anti-pattern for that is that they create the environment, they have these golden images, and those golden images, they take months and months to create. and people use them, but it takes months and months or sometimes weeks to create an environment that's based on those with all the specific compliance issues, because they're not using pipelines. They're using manual, handwritten, sometimes scripts and sometimes their own handmade scripts. The amount of tooling that's required to support such an endeavor is huge. There are many different types of tools. There are many different types of variations of doing the same things. And everything that you do, you can choose which tool you want to use. So let me tell you this. One of the worst mistakes that organizations make today when they come in to adopt DevOps is that they've already selected the tools. The best thing you can do for your company, if you're just starting this, is to delay the decision of which tool to use until you know what your pipeline is supposed to look like. And the way you know how your pipeline should look is because you created this value stream at the beginning, and you know what are all your handoff states. And once you know them, you can actually design the pipeline, and then you know what are the requirements you need from the specific tools. There are some basic requirements that you can have from specific tools. For example, all tools should support automation, right? All tools should have an API so that either Jenkins or TeamCity or whatever server you're using can actually invoke them and get the result back. But there are other requirements sometimes. Tools should be able to run in parallel, right? If you have a tool that scans your code for security vulnerabilities, but it can only run in sequence, but you have X amount of projects in the queue, you will have to wait a long time because you cannot parallelly check that code. So you have to design licensing schemes, etc., to support running things in parallel as well. So as you design the pipeline, then you decide which tools are the right thing. And in many organizations, we design the pipeline, and then they say, yeah, but we have to use this specific tool. Unfortunately, to do this specific tool, everything has to be done through the portal. You have to click, etc. And we want a tool that you can actually store the configuration through code, right? And many companies have already made an investment. The sunk cost fallacy happens a lot. And part of the adoption pain is to convince the company that some tools are actually going to hurt more than other tools. And one of the best ways that I found to accomplish the task of convincing a company to switch to a different tool, or really switch to different types of behavior, is with the best tool in the world, the Excel file. The Excel file, a simple table that shows what we're doing today, putting an hourly cost on it, on how much time we're losing by doing things the way we are today, versus how much it would cost by doing it in a new way. So the idea is to change the way we speak and say, how much does it cost us not to do it? For example, we want to use, the company doesn't have enough licenses to run multiple agents for TeamCity, if you're using TeamCity. Well, how much time does it cost us not to have those agents, extra, let's say, 20 agents to run project in parallel? Well, you take your logs and you say, well, if I have a developer waiting on average 30 minutes per build because there are multiple builds happening, and I have X amount of developers waiting, that's X amount of hours per day of people waiting. How much is in 1 hour of developer? How much am I losing per week, per month? Okay, that's how much I'm losing per month. This is what the cost of the licensing is. Usually it returns itself within the first month. And that's an example where managers who have budgets can connect with you. Because at the end of the day, they need to see that there is a difference. Why I've already spent all this amount of money, but for this one-time difference, I can stop losing or hemorrhaging this amount of money. I like to describe DevOps as this huge pipeline in the company that everyone has to jump on, because DevOps is a combination of multiple things. There's different things for different organizations inside the company, for security and compliance and testing and development and marketing. Everyone has to be on board, and a single pipeline as a single application, a single pipeline per application will take them forward. If some people are off the elephant, and they're running in parallel, then they will not care about the outcomes, or they will not be invested in this. So if we're talking about the DevOps at the enterprise level, we're talking about an enterprise that adopts a pipeline mentality. And the pipeline mentality also includes not just running unit tests and integration tests, it also includes Compliance. And in many big companies, compliance is a huge issue. So what is a pipeline really, if we think about it? If every stage of a pipeline, when we move from left to right, every stage is really a quality gate, right? You've passed the unit test, you've passed the integration, you've deployed to this, if you run these smoke tests, you run this load and performance and security. Each stage is really a test. It is a quality stage. And policy and compliance is just another policy, is just another stage, is just another test. So one of the challenges in large organizations is to talk to the policy team. Sometimes it's people with actual legal experience. Sometimes it's people that come from the industry. When I was working in a large healthcare company, it's people who know about drug laws, etc. And the idea is to, first of all, outline what are the policy or compliance decisions that they have to make before a release. When they actually have to check off and say, okay, I'm okay with this, I'm okay with this. And then see what can be automated, and usually things can be automated. For example, I verify that all of these documents are in place. I verify that all of these documents have a signature. I verify that the audit trail exists for this thing, because compliance really is about visibility and about protocol. And protocol, especially when you have full automation, is actually much easier to achieve. So in many organizations, it can take months, but the idea is that you end up with compliance tests. And there are also tools in the market, like Chef Compliance, etc., that can check specific types of compliance problems. For example, firewall, security, network, etc. And one of those, and each one of those can actually get into the pipeline and be a part of a test. And it wraps the pipeline here, but really what it looks like, it's just another stage on the way to production. If you didn't pass the compliance stage, you're not deploying. And when you get those people to sign off on the fact that if the scripts that they help write, they help design, if those scripts say everything is okay, then they're okay, that is the beginning of that agile compliance. The second thing that happens is that in large organizations, you create what we call a tiger team. A tiger team, the beginning of a team that creates an exception for a specific project. Because usually when we want to adopt, we don't adopt at the entire organization level, we start with the pilot project. And the pilot project usually is a single project. You take a specific piece of component or an application or two applications that depend on each other with some risk, but not the entire risk. It has to be something that actually matters to the company, something actually visible, not some science experiment. And on that, you create an exception for compliance. You call it an agile compliance policy. And you create a temporary exception until you have a full and realized compliance policy at the company level that allows full automation. So all the other projects are still working kind of a waterfall. But this one single pilot project has an exception, which is the reason that that specific project is allowed to deploy to production. Now, it can take, again, a couple of months to sort that out, because if you're deploying to public cloud and you have PII type of information, et cetera, you work those things out. For example, it has to pass encryption guidelines, et cetera. You pass those things, you come up with that compliance delivery policy, and suddenly you have a new stage in your pipeline. Isn't it correct? Interesting. Okay. Let's see. The biggest DevOps battle that I've had was usually about policy, because it's the thing that everyone assumes cannot be changed. It is one of the only things that people usually just say, that's the way it is. We're not going to be able to change it. But really, in the company level, when you have CXO level, right, CTO, CSO level, usually there are people who are engaged or can be engaged in that process. And those people give permission for a compliance targeting to be created to just look at the possibility. We might not end up with something, but it's an experiment. Because they know that if we are able to do this, because so many other big companies are able to do this somehow, then we will gain that kind of ability to deploy much faster in a much better way. But let's zoom out for a second. In a large company, we don't have a single project, right? In a large company, we have many different projects talking to each other. and they have many different types of dependencies. When you try to talk to a single project and you want to lift and shift that project, you have to understand where the inputs and the outputs of that project are coming from. One project breaks and suddenly another project at the other side of the organization breaks. And so when you're consulting to these companies, what happens is that you start with the team and you start questioning, how do you do this? Where do you get this? Who do you get to do this? And then you start finding out more and more people, and the circle actually becomes bigger and bigger. And you realize that the amount of people required to deliver a feature can be hundreds. Because a feature goes through all these different handoffs, different teams, different requirements. Understanding that is one of the biggest things. And if you try to take all of them together at the same time, it's going to be a recipe for failure. Because when we're talking about big bang transformation, what a lot of executives see is, we start here, and then we throw some money at it, and then after some time goes by, we're agile, and that's good. But really what happens is this. Many different types of baby steps that we can take. Because if we take each one of them separately, and we take things very, very slowly, we make quick pilots that achieve everything. Now, when I do this talk in front of executives, and I wear completely different clothes, right? And I explain this to them, everyone goes like this. Absolutely, yeah. It's a great idea. We should definitely do this tomorrow. And then they go in and they start big bang transformation anyway. And they go, everyone in this company has to do DevOps now. All the environments, everyone use this, and you work with that person, and you work with that person. Everyone feature teams now. And there's this kind of order from the general. And that usually doesn't work. What happens is that it works for the first week. And then after that, everything stops. Everyone is in chaos. Everyone doesn't know what the hell is going on. There's panic, and almost immediately the middle management comes into the big manager and say, what the hell? We're not able to do anything. This team is doing this, and we're even stuck. We're trying to, and they're not, and nothing. They don't even know how to explain what their problem is. All they know is that they're trying to do something, and they're trying to do exactly what you told them, but they're not able to, because when the organization adopts that kind of thing, they don't think about those external things like security and compliance and the policies of the organization. So now you're asking people to specifically go against the policies of the organization, which of course is going to be a miserable existence for them. And so there's an abort. And after the abort, if you are able to go through that, you might succeed. So in a pilot project, we want baby steps. We take this approach, but in a single project. One pilot, maybe two teams. And for those teams, we are able to go through that kind of fear phase. And what happens usually is that once the team is able to create that pipeline, we take the pipeline and we create a template from it. A template, either technical or methodological. We say, if it worked for this team, let's try to apply to 2 more teams. And the people from this team become the champions of the other teams. Because they've been through all the crap of deploying something in this company. And now they're able to go through it and say, this is how we successfully did it here. Oh, no, just don't even look at this. Look at that environment. Oh, here, set up a Jenkins. Okay, this is the base Jenkins file that we used, and this is what you use. Oh, no, we have an exception policy for the deployment. Don't worry about it. Do you need a unit test or integration, or what type of test do you need? So that's where it begins. Now, in a large organization, you have different types of teams. A recent organization I've been working with, they have a mobile team and a web team and a server, etc. So even though we were able to do it in some teams, the pipeline does exist, but when you come into a new team, you have to completely rethink about the tooling for the pipeline that you've designed. You want to think about the tooling in terms of not just coverage, but also of how it connects to the pipeline. So for Android type of smoke testing, integration testing, and unit testing in Android, and then the same for iOS, you have to come up with all of these tools that cover all those scenarios, because the pipeline already exists. You just have to support different tools that support the same notions. And each team then customizes the pipeline to their own requirements. Okay. A couple of things before that happened before adoption is that people are very, very excited. And then when they start to actually adopt things, so for example, management is saying, okay, let's do a go-ahead, and then we work with the people at the technical level, that the understanding of just how much change there is to the day-to-day culture is missing. And that change is, a change in the way that you work with people, the change to the culture, the architecture can change, the process and the practices and the tools. So the tools is the easiest part, and the tools is also the last part that we want to change. What we want is to start to understand just how many types of people you have to learn to live with. And usually developers are very reluctant to work with people that do not share their own specific background. I mean, some developers are, and they should be really happy to do this, but these are an example of the amount of people that you have to have on your team in some form or another to be able to actually accomplish something. Now think about the organization, the largest organization you've ever worked with or in, and think about how easy it is to assemble a team made out of all of these people sitting in the same room, at least for half a day or several weeks, where they can actually work together to deliver something. When we're talking about a feature team, this is an example of a feature team. Do you notice what's missing here? What's missing here? Sorry? Business. Business is usually the PMO. Testing. All the testers in the crowd like, I knew nobody noticed me again. The testers are part of development. Developers and testers are one and the same. So part of the thing that we want to have in those grouped teams is that in those teams, the testers learn how to code if they don't know how to code. So you literally go through this kind of an education program with them. And as they learn, they also learn how to code and do pair programming, but they also become coaches. So if I'm a test architect at the team, I know a lot about testing. I know a lot about different types of testing. And I have a thought process about testing. Many developers do not have that same thought process. They code something, maybe they do test-driven development, but they still think about things maybe in component terms, etc. And part of my job is to teach them how to think like a tester, think about different types of tests, think about higher level tests, and teach them how to automate things the way I already know how to automate things, so end-to-end testing, etc. Because developers and testers, they write the tests together during the iteration or non-iteration. It doesn't matter what the process is. When you start something, you already begin with the design of the tests, because for every feature, you have to have something, a stage for it in the pipeline that makes sure that it passes that. So for that feature, I have maybe a compliance test, and a security, and a performance, and a load, and a unit, and an integration. There are all types of testing. DevOps is all about testing. DevOps really is the one place where testers should be the most happy, because everything is a test in the DevOps world. Everything, an infrastructure test. Because a pipeline is a huge test. A pipeline is a big red or green. That's all it is. You just make it go through all these specific exercises. So teaching all these people to talk to each other is one of those things that is very, very awkward on the first couple of weeks. Just getting these people together. And to get them together, you have to have management buy-in. Imagine you're sitting in the same room with a person you've never seen before, but you know that they've made all the decisions to make your life miserable for the past year, like the network person. And now you have to work with that person. So sometimes there's this animosity, or the people have to learn how to live together. And it's part of the sometimes fun. Because when I was a developer, the best thing I could ask for is for the security person to tell me why they decided what they did. Why did they say no to this? Why does it take a week for something to accomplish something? Because it's like a black box to me. But when they're in the same room as me, I can have a conversation. And that's part of the leadership that we have to give people, to explain that this is a huge power-up to the team. Because everything can be understood and explained without waiting. And everything can be discussed openly. And decisions can be made. So connecting with people across the organization, the core skill becomes the people skills. So teaching people and coaching them on how to work with other people becomes a core skill for tech leads or scrum masters or whoever it is. Because one of the things that people don't know how to do is how to work with other people, especially if they've been technical their whole life. They know how to work with a computer really well. But to communicate ideas or to teach other people, one of the things that I do most when I teach developers about DevOps and I teach them about pair programming is I teach them to let go of the keyboard. And I say, let the person with the less experience write more of the code. And people find it so difficult because that person does things slower. And they do things sometimes badly and they have to learn. Everything is kind of a learning exercise. And those people do not have the patience or the skill on how to teach. But in a DevOps world, a teaching skill and a skill of working and pairing with other people is a core skill. So if a person cannot handle that in my team, then that person will not be able to be on my team. Now, if I cannot, so my job is to teach that person how to coach other people. Make sense? So I coach people on coaching people. Now, my next job is how to coach people to coach people to coach people. There's always a meta level to it. But the idea is that everything that the team doesn't know how to do, there's a skill that they need to learn. And so what we want to do is we want to teach them how to think in that new way. Okay, so we have 5 minutes left. I want to cover some questions before we finish today. But before I do, some books that I want to recommend. There is a book called Testing in DevOps. It's a relatively new book. I recommend that you give this book to the testers in your organization that are interested in this. Because a lot of what I talked about, this book talks about in testing terms, from one tester to another, of how the world changes from a testing perspective. The book Continuous Delivery is really kind of the Bible of the ideas we mentioned here. And there's a new book, the DevOps Handbook, that is, it's kind of a summation. I would say it's a really good learning book for high-level management because it's very, very short and the fonts are big. No, but it's a good book because it talks about metrics and the high-level organization and some of the ideas that I talked about before. Okay, let's talk about some questions. Is there a question? Do companies which deploy already of marketing exist? Which deploy ahead of marketing exist? Yeah, well, Amazon is an example of that company. Amazon will deploy things and do A/B testing on them just to test how things are behaving. There are quite a bit. Well, that disappeared. That's really a good sign, right? So yes, the answer is that a lot of companies will deploy ahead of marketing. And if we're talking in the enterprise space, there are some big companies that deploy ahead of marketing. And one of them is actually a sponsor in this conference. Do you know who it is? It's a big company. They employ a bunch of people here, probably. Their name starts with Wix. Okay. Are there any other questions we want to ask here? Okay. So thank you very much, everybody. I'll remind you that on Sunday, I'm going to do the full-day workshop. And in that workshop, we're going to cover on how to actually do the value stream. What does it take? What does it look like? And we'll talk about much more about